I think so, but okay. Oh, I know what's going on. Okay, are y'all ready? We're going to go over the homework. So on the first, this classwork, on the first two, you had to say how many degrees that it had. I was way too large there. How many degrees that each of these had. Remember, you're not going to know what the polynomial is. You can only tell how many degrees it is. You hearing me? Okay. So you find the first difference, second difference, third difference, however many that it takes before you know how many degrees it has. Okay? So remember, we do 0 minus, and in this case, I will be subtracting a negative. So what do I get? Positive 8. 24 minus 0?
24.
So is this going to be linear? No. 70 minus 24? 26? Pardon me. 144 minus 70?
74.
And 252 minus 144? 108. Okay. So it's not linear because our first differences are not constant. Okay? So what do we do now? We find the second differences. Okay, kids? So we do 24 minus 8 is 16. 46 minus 24. 74 minus 46. I need your attention, please. 108 minus 74.
34.
Does this have 2 degrees?
No.
No. What do we call a polynomial with 2 degrees? A quadratic. It does not have 2 degrees. Dietrich, bring me that phone. Oh, what is that? You're playing it like a video game. I apologize. Okay, so it's not 2 degrees because the second difference is not constant either. Dennis, I'm going to need you to go to your seat because y'all can't stop talking and you're in the wrong seat, or someone is. Okay, then who's in your seat? Justin? Justin, can you move over one on the other side of Elena? Can you see this? Okay. Alright, so what do we do? So what do we do? We're going to try and find the third difference. Maybe it'll have 3 degrees, right? Maybe it won't. I don't know. So what is 22 minus 16? 6. What is 28 minus 22? 6. What is 34 minus 28? Winner, winner, chicken dinner. We found it. The third difference is constant, right? So that tells us how many degrees do we have? 3 degrees is called what? This is a cubic, and we can only say polynomial. We don't know how many terms that it has. We only know that it has 3 terms, 3 degrees, okay? Everybody good with that? Yes, Miss Fraley. Okay. Next one. How many degrees does it have? Before we start, y'all tell me. 2? Okay. Let's see. What's 16 minus 11? 5. 15 minus 16. Okay, so we know it's not 1 degree. 8 minus 15. Negative 7. Negative 5 minus 8. negative 13. Negative 24 minus a negative 5. Now that's going to be negative 24 plus 5, right? Double negative makes positive. So what was it? Negative 19. Now we got another crazy one. Negative 49 minus negative 24. That makes negative 49 plus 24, and it's negative 25. Negative 80 minus negative 49 means negative 80 plus 49, and you get negative 31. Not 1 degree. This is not a linear function. Am I right?
Right.
Alright, let's see if it is a quadratic, 2 degrees. So I'll find the second difference. Bless you. What's negative 1 minus 5? Negative 6. Negative 7 minus a negative 1. Negative 6. Negative 7 minus negative 13.
Switch it. 7 and 13.
So what is it?
It's negative 13.
Oh, I did it wrong. I see what you're saying. Should be negative 13 minus negative 7, which is negative 13 plus 7, which is negative 6. Sorry about the math. Negative 19 minus negative 13. Negative 6. Negative 25 minus negative 19. Negative 6. Negative 31 minus negative 25. Negative 6. So, how many degrees does this have? 2 degrees. What do we call a polynomial with 2 degrees? Quadratic. Do we know how many terms it has? No. What? I know, but I'm looking at my face. So it looks like I'm looking over there. I don't over there. Over there. Over there. I don't know. But if I look at the camera, then I can't see what I look like, so I look like this.
No, but if you look at the camera, then it's like this is straight
Hi.
entrance.
How you doing? Okay, so 2 degrees is a quadratic polynomial. What do we call a review? What do we call a polynomial with 1 degree? Linear. 2 degrees, quadratic.
You use it as a mirror.
But I can't because I can't see myself when I look directly into the camera. 3 degrees, cubic. 4 degrees, quartic. No. 5 degrees, quintic. Did I tell y'all that I learned what 6 degrees is called? Bring me that phone. Trickery. Sorcery. 6 degrees is called, did I tell y'all? Sextic. 7 degrees. Septic. 8 degrees. Octic. Do y'all just know this or did I tell you? 9 degrees. Nonic. 10 degrees. Decic. Decic, I think. Decic. Yay. Okay. Any questions on this? Section 6, topic 6. I will be showing this video in my later class because they'll have this today as well. But I won't post this on Edmodo because it's the homework.
So it shows exactly like that, right?
Yes. Isn't it fun? I told you I'd be fun.
Return the paper in.
Yes. Alright, on the first one, you had to determine the multiplicity. The polynomial was given to you in factored form. Can I look at this polynomial in factored form and know how many degrees it has? Yes. Do I have to multiply it all out to know how many degrees it has? I know. All I have to do is multiply my first terms together. Okay, that's where all my variables are. So what is x times x times x times x?
X to the 4th.
X to the 4th means there's 4 degrees. Means how many solutions am I going to have?
4.
4 solutions. Real and or imaginary. They might all be real, but you might have some imaginary solutions in there as well, right? Where you get a negative under the radical. But altogether, you're going to have 4. So if you come up with more or less, something's not right. Also, just by knowing that, I don't have to multiply the whole thing out to know what the end behavior is going to be. What's the end behavior, kids? Up and up. Not that I'm graphing this, just a review. Okay, it wanted to know the multiplicity. So to know the multiplicity, that means I have to know the solutions. And if it's factored, what do I do to find the solutions? Every solution equal to 0, even the x? Yeah. It's a variable. It's going to give me a solution. So I have a solution of 0. I have a solution of positive 2. I have a solution of positive 2. And I have a solution of negative 2. Boom. So 0 has a multiplicity of what? 1. It's because it occurs one time. That solution only appears once. Positive 2 has a multiplicity of 2. And not because it's the number 2. It's because it appears 2 times. 2 of my solutions are the same. Negative 2 has a multiplicity of 1 because it only appears once. So I have 4 solutions. My graph could potentially cross the x-axis 4 times, but how many times does it cross in this case? 3. Because when you have 2 solutions that are the same, it's not going to loop back around and cross that same x value more than once. You know what I'm saying?
Yeah.
Okay. And the last one, you had to sketch a graph. And the graph is g of x plus u equals x times x minus 1 times x minus 3. Do I have to multiply this all out to know what my end behavior is or how many degrees I have? No. How many degrees do I have? 3. Because x times x times x gives me x cubed. So 3 degrees means I have how many solutions? 3. So it can't cross the x-axis any more than 3 times. And what's my end behavior? Down and up. B-H-A-V-I-O-R. Right? Down and up. Y'all are going to have to memorize the end behavior before the test because I will not be telling you that. You have to know that. Down and up. Whenever your leading exponent is odd, it's opposite directions. Either up, down, down, up. Okay? So we know that. So then you look to see if it's positive or negative. If it's positive, it's going to end on a positive note. End meaning the right side. That means if it's opposite directions, the left side would have to be down, correct?
Yeah.
If it was negative x cubed, it would end on a negative note, meaning the right side would point down and the left side would point up. Y'all remember it however you need to, but that's how I remember it. If it's even degrees, it's either up, up, down, down. Up, up if it's positive, down, down if it's negative, right? Okay. It's like a little dance. And y'all thought this camera wouldn't be cool. Okay, I'll stop. Alright, so first of all, let me see where my graph's going to cross the x-axis. I'll find the solutions. So it's going to cross at 0, positive 1, and positive 3. Right on?
Right on.
So that's the first thing I'm going to draw. It's going to cross the x-axis at 0, positive 1, positive 3. What's my end behavior? Down and up. The first word talks about the left side of the graph. The second word talks about the right side. You read a graph left to right. So if the left side's going to point down, go to your 0 that's to the furthest most left and just kind of sketch an arrow pointing down. The right side's going to point up, so go to the 0 to the furthest to the right and kind of sketch. Now we don't know how narrow it's going to be or how not narrow it's going to be. It's just a sketch on the end. Okay, if you want to know exactly, pick you some x values. Plug in x is 4, x is 5, x is 6. Substitute that into your equation and find y values. If you don't remember the end behavior and you have to sketch, that's what you're going to have to do. Pick some x values to the right and to the left and put them into your table of values and find ordered pairs. And then plot those and you can see if it's going up or down. Okay? But is this my graph? No. I've got to figure out what's happening in between these two zeros because I know it's not just a straight line over here. And I have to find out what's happening in between these two zeros. So pick some value of x that falls in between each. So between 0 and 1, what could I pick? 0.5. Is that what I have to pick? 0.2, 0.7, 0.89634, if you so choose. I would go 0.5. How about between 1 and 3? 2. Again, it's not what I have to pick. I always just go right in the middle. So I'm going to make a little table of values. Where shall I do this? You can use factored form or standard form. This was only given to us in standard form. So that's what I'll choose. And I'll substitute in 1/2 first, or 0.5. So 0.5 times 0.5 minus 1 times 0.5 minus 3. So we simplify inside those parentheses first. What's 50 cents minus $1?
Negative 0.5.
Negative 50 cents. What's negative 50 cents minus $3?
Negative 2.5. Negative 2.5.
I don't think so. You borrow 50 cents from me. And then you borrow $3 from me. How much have you borrowed from me? Negative 350. Because the signs are the same. So you add the 0.5 and the 3 and keep the sign, right? So that should be.
Not negative.
What's not negative? It says x minus 3, unless I wrote it wrong.
No, you're talking about both sides.
Oh, this is a positive 0.5. Okay, I gotcha. Yes, negative 2.5. I don't like when my mistakes are on the video. Okay, now I'm multiplying all of these together. It's all multiplication, correct? So 0.5 times negative 0.5 times negative 2.5. What'd y'all get?
0.6.
Okay, good. That's what I got. So when x is 1/2, y is 0.625. And I'll go back and plot that in a minute. I'm going to go ahead and substitute in 2. So that's 2 times 2 minus 1 is 1, times 2 minus 3 is negative 1, and 2 times 1 times negative 1 is?
Negative 2.
Negative 2. When x is positive 2, y is negative 2. So my first point, when x is 0.5, y is positive 0.625. So approximating. So now I can just connect those points, right? And the point that I found between 1 and 3, when x is 2, y is negative 2. So then I can just connect those. And this would be a lot smoother. If you wait to put your end behavior on until the end, you can make it kind of look more flowy. I've got a relative maximum, a relative minimum. What is my domain? What is my domain? Anyone? Anyone? What? Guess. What does domain mean? Seriously? All possible x values. Think about it. Is there any number that I could not substitute in for x and simplify to get a y value? Any real number. So all real numbers. I could plug in any number for x and get a y value, right? There's no number that would not work. So my domain is all real numbers. Or remember, you could say negative infinity to positive infinity, or you could literally say all real numbers. My range from all possible y values, when you answer that question on the test and say all possible y values, that's the definition of range. That's not the answer, okay? Range, I like to look at the graph, okay? Is there any point on my graph that has a y value of 0? Yeah. How about 1?
Yes.
How about 2? 3? 4? 5, 6, 7, 8, 9, all the way to positive infinity. Okay, because that arrow's pointing up, right? Is there any point on my graph that has a y value of negative 1? I got 3 of them. How about negative 2? Negative 3? Negative 4? This is pointing down with an arrow all the way to negative infinity, right? How about negative 1 million? Negative bazillion? Negative infinity? Yeah. So your range, in this case, is all real numbers. When your graph is, when your ends are pointing in the same direction, up, up, down, down, your range is going to have some sort of limit on it, okay? But if you've got an arrow pointing up and one pointing down, it's going to be all real numbers for domain and range. Your domain's usually all real numbers on when you're graphing polynomials, okay? Okay? Okay. Any questions on this? I went over this in detail. A lot of people are like, I don't get any of this. Do you feel a little better about it? Because this test will be coming up a lot faster. There's not a lot of sections in it. We skipped 2. 2 of the sections we doubled up in the same lesson. And so, you know. Okay. Make sure your name's on them. I did not mark them. I need to collect them. I will mark them then. Your grades have been completely updated, except for this assignment. Pass them over.